This video contains the solutions to the calculus of vector-valued functions practice problems. So here we're just asked to find a tangent vector to this function at t equals 1. So it's written in ijk notation. I find it a little bit more convenient to convert this to the component notation, so I'm going to just go ahead and do that. So r of t equals 2t to the fourth, 6t to the 3 halves, and 10 over t I'm going to rewrite as 10t to the minus 1. That's something we often do when we're going to take derivatives, to rewrite fractions in terms of negative exponents. So the tangent vector is just going to be the derivative of this vector-valued function. And when we take the derivative of a vector-valued function, we take the derivative component-wise. So it's just the derivative of the x component, 8t cubed, the derivative of the y component, 6 times 3 halves is 9, subtract 1 from that exponent, I get t to the 1/2, and then negative 10t to the negative 2. So that's my general formula for the tangent vector, and they want to know the tangent vector at t equals 1, so I'm just going to plug 1 into this function. So that gives me 8 times 1 cubed, 9 times 1 to the 1/2, and then negative 10, 1 to the negative 2. So that's just going to be 8, 9, negative 10. So a very similar problem here, but notice that there's one key word that's different, is that they're asking for a unit tangent vector. So we're going to start doing the exact same thing we did in the previous problem, but we're going to have some extra work to do at the end. So this one's already written in component notation, so I'm just going to take the derivative of each component. The derivative of cosine 2t is negative 2 sine 2t. The derivative of 4 is 0, and the derivative of 3 sine 2t is 6 cosine 2t. Now plug in pi over 2. That gives me negative 2 sine 2 times pi over 2 is pi. 6 times cosine 2 times pi over 2 is pi. Now the sine of pi is 0, so that's 0, 0, and the cosine of pi is negative 1, so the tangent vector is 0, 0, negative 6. Now is where we have to do some extra work. They're asking for a unit tangent vector, which means we need to find the magnitude of this tangent vector, and then divide our tangent vector by that to turn it into a unit vector. This one turns out not too bad to find the magnitude. It's just going to be 0 squared plus negative 6 squared. That works out to be 6. So my unit tangent vector is just the tangent vector divided by that magnitude. So that's r prime of pi over 2 divided by the magnitude of r prime of pi over 2. So that's 0, 0, negative 6 divided by 6. That's 0 over 6, 0 over 6, minus 6 over 6. That's 0, 0, negative 1. And that's my unit tangent vector. Taking this one step further in this next problem, now we're asking for a formula for the unit tangent vector. So we want an actual expression, not just one specific unit tangent vector at a given point like we did in number 2. This one we want the formula for the unit tangent vector in general. So the process is basically going to be the same, it's just going to be a little bit nastier because our answer is going to be algebraic rather than numerical. So we find our tangent vector, so the derivative of t is 1, the derivative of 2 is 0. Thinking of 2 over t as 2t to the minus 1, the derivative of 2 over t is negative 2t to the negative 2. Now I'm going to rewrite that in fraction form just because it's going to make it a little easier to do the algebra that I'm about to do. So negative 2 divided by t squared. So to find a unit tangent vector, we take the magnitude of the tangent vector, and we're going to divide the tangent vector by its magnitude. So the magnitude here is going to be 1 squared plus 0 squared plus negative 2 divided by t squared squared. And that works out to be 1 plus 4 over t to the 4th. Now I'm going to divide by this, so I don't really want to divide by an expression that has a fraction inside a square root. That's just going to be a really horrible algebraic expression, especially because they're asking us to simplify our answer. So I'm going to find a common denominator inside that square root. So that's going to give me t to the 4th plus 4 divided by t to the 4th. And then the square root of a fraction is the square root of the top divided by the square root of the bottom, and the square root of t to the 4th is t squared. So that's going to be a little bit nicer when I do the next step. So my unit tangent vector is r prime of t divided by magnitude of r prime of t, and that's going to be the vector 1, 0, negative 2 over t squared divided by this fraction, square root of t to the 4th plus 4 divided by t squared. When I work that out, that's going to give me t squared divided by the square root of t to the 4th plus 4, 0, and then the t squareds are going to cancel out, and I'm going to get negative 2 divided by the square root of t to the 4th plus 4. And that ugly mess is my unit tangent vector. Now for these last two questions, we're asking about integration type of problems. So here I'm giving you the tangent vector, I'm telling you what r prime is, and I'm asking you to tell me what r is. So just like if this was a question back in Calc 1, if I give you the derivative and I ask for the original function, what I'm asking you to do is integrate. So r of t is just going to be the integral of r prime of t dt. Now how do we integrate a vector-valued function? Well, we just integrate each component. So this is really just sort of 3 Calc 1 problems all packaged into one Calc 3 problem. So we take the integral of e to the t, we get e to the t. We take the integral of sine of t, we get negative cosine of t. And we take the integral of secant squared, and we get tangent of t. And just like in Calc 1, whenever we do an antiderivative, we have a plus c. But in this case, the c is a constant. C is a vector, so it's a constant vector, and now our task is to figure out what that constant vector is. And we're going to use the fact that we know that r of 0 equals 2, 2, 2. So from our formula, we know that r of 0 is going to be e to the 0, negative cosine of 0, tangent of 0, plus that mysterious vector c, but we know that that's supposed to equal 2, 2, 2. E to the 0 is 1, cosine of 0 is 1, tangent of 0 is 0. Subtract 1 minus 1, 0 from both sides, and that gets us that c is 1, 3, 2. So that means that my vector-valued function r of t is e to the t plus 1, negative cosine of t plus 3, and tangent of t plus 2. In the previous problem, we did an indefinite integral. This time we're going to do a definite integral. But again, it's really just 3 Calc 1 problems, I should say, packaged together into a single Calc 3 problem. So again, it might be helpful to rewrite this in terms of the component notation. So my x component is 1 because it's just I, which means I have 1i, t, and then 3t squared. So all I'm really doing is integrating from negative 1 to 1 each of these functions. Antiderivative of 1 is t. Antiderivative of t is 1/2 t squared. And antiderivative of 3t squared is t cubed. Plug in 1 and subtract, and in this case we get 2, 0,